All right, your goal today is to watch this video, complete the practice quiz. You must turn it in, and it has to be 100% correct. So whether you do it before you watch the video or after or during, whatever you do, this has to be correct. After that, you're going to turn it in. We're going to give you points, and then you're going to continue working on your quadratics practice that is due on Friday. It's probably a good idea for us to check some of your problems so you can get as many right as possible. So I'm going to walk you through these problems step by step. Some of them have different ways you can do them, so I'll show you both ways. If I highlight something, I suggest you highlight it. So if you want to go grab a highlighter, grab a highlighter, and I'll be giving you helpful hints along the way. So in number 1, you're looking at the rhombus at the right. You're finding what the measure of CDB is. It's always good practice to highlight or do something with the angle you're trying to find. You're trying to find CDB. So that is this little guy right there, okay? We have a rhombus. All that means is we have 4 equal sides. Okay? So since you know the sides are equal, I would mark the sides. Mark, congruent, congruent, congruent. So the first way I'm going to do this is by using an isosceles triangle. Okay? So if you notice, if I cover up one side of this, okay, so let me see if I can, okay, so if I cover up that side and make it look like it never even existed, you can see that you have an isosceles triangle. So I would redraw the isosceles triangle, and you can still see the angle you're trying to find, B, C, D, and here's the angle you're trying to find. So that would be the base angle of an isosceles triangle. Well, you could do that. You can do 180, take away what you know.
Sarah Bailey, you have a call on line 1. Sarah Bailey, line 1.
I have to pause this video while I get at my call on line 1. Alrighty, I'm back. Alright, so we were finding the missing angle of an isosceles triangle because I split that rhombus in half. So there's 125 degrees left to be split evenly. So 125 divided by 2 is 62 and a half, which means our angle is 62 and a half degrees. Okay? Now I'm going to do it using the rhombus rules. I'll do this one in blue. So I will put a, okay, rhombus. So as we know, a rhombus is a quadrilateral, which means all of these angles, all 4 of those, need to add up to 360. Okay? We also know that opposite angles are equal. So we have 2 equal angles there, and then we have 2 equal angles with the 55. Okay? So let's add up what we know, 55 and 55. And that gets you to 110. Subtract that from 360 because there's 110 taken up, and there is 250 left, but 250 left to be split evenly amongst those 2 other end angles. Okay, so 250 divided by 2 is 125. So then each end angle here is 125. But we only need half of the end angle, so we do 125 divided by 2 to get 62 and a half. Either way is correct. All right. All right, the next thing we're going to do is a problem like this. So we want to turn that flower counterclockwise onto itself. So the smallest angle we're going to use, you first have to count the number of petals or spokes or whatever it is, and there's 6. All you have to do, 360 divided by 6, 60 degrees. That should be an easy one on your test or your quiz. Okay? Number 3, you have your regular hexagon, which means the sum is 720. Okay? Each interior angle is 120. So your sum of your interior is 120, sum of your exterior is 360, and one exterior angle is 360 divided by 6, which is 60 degrees. All right, we want to know the measure of M and L. So the first thing you want to note is that N is the vertex of that angle. So we want to draw diagonals from N. Okay? So that's how you know where to start with your diagonals. So N to L, and the diagonals are splitting that angle evenly. So they split all of that angle, that's 120, into 4 parts. 120 divided by 4 is 30. So each little angle is 30. But we need the measure of angle M, N, L. So that is 2 parts. From M to N to L is 2 parts. So we have to do 30 plus 30 to get 60. All right? Okay, next one. The exterior angle to the vertex angle of an isosceles triangle is 70. So the exterior angle to the vertex, which means these are equal. All right, you got to find your linear pair, 180 minus 70, 110. And then you got to take away 180 minus 110, 70 degrees. 70 divided by 2, because they are 2 equal angles, 35 degrees. Or you might notice, inside plus inside has to equal that exterior angle, so you could have just done 70 divided by 2. All right, number 5. Woo, number 5 is a doozy. First thing you want to know about number 5 is it's a kite, which means 2 sides are congruent. So I'm going to mark the 2 sides that are congruent. Okay? So what that means is this side has to be 15. So we know 4x plus 3 has to equal 15. When you solve that, x equals 3. Okay? So then YD obviously is 15. The other thing you know is this side, oops, different color, has to equal this side. Okay? So you have this equation. Luckily you know x now, so 12 times 3 plus 5y will give you that. Usually we don't do it this way, but 36 plus 5y. That equation has to be 27. So 36 plus 5y equals 27. Okay, let me grab a calculator. 27 minus 36 divided by 5, oh dear. Unfortunately, y is negative 1.8, which is totally cool. But we do know that side CO is 27. Okay? The next thing you know is that this guy right here is 24. Well, that's a symmetry line, so we know CS has to be 24. And then gee whiz, the whole thing, CD, has to be 48 because it's half. Whatever on that side is on that side. Pretty sure that's the only side lengths you can find. Number 6, everybody's favorite question. You have isosceles triangles here. You want to use them. Angle Y is 25. Segment YZ is congruent to segment XZ, which means these are the base angles. That side is 25. The missing angle of that other triangle, or the missing angle of the triangle is 130. Add up what you know, subtract from 180. Move over to the other triangle, they form a linear pair. So this guy is 155. So if you don't need to write all of the 180s minus 25s out, that's fine. And then we know XZ is congruent to XW, which means these are equal. Those little guys end up being 12 and a half, 12 and a half, missing angles of an isosceles triangle. And then our question wants the measure of YZW. Okay? So 130 plus 12 and a half is 142 and a half. Okay? All right, number 7, regular pentagon. All the angles add up to 540. What is the measure of BAD? BAD, that means you draw all your diagonals from BAD, from A. So each angle in the pentagon is 108 degrees. And then this guy gets split up into 3 equal parts. So 108 divided by 3, I believe that is, dun, 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 sorry if I'm annoying you, 36. So each little guy is 36, 36, 36. And then we want from B to A to D. So we need 2 of those guys. 36 plus 36, dun, 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 dun. I should know this in my head, 72 degrees. Bam. Alright, number 8. Oh, favorite question. Isosceles triangle with angle P congruent to angle R. Mark those angles and the sides opposite them. So we know 4x minus 9 has to equal 17. Solve that. X is 6.5. You should definitely be able to solve that. And then all you do is substitute in this side PQ should be 17 and PR is 16. All right, number 9. This is a toughie. Number 9 is finding the measure of KIM. Okay, so it's that angle. We know that the diagonals of a kite intersect at a right angle. So that guy right there is a right angle. So if you redraw, you have K and I, and then we can just call this A or something. But we know it's a right angle, and we need to find that guy. We also know that the diagonals of a kite bisect the end angles, so that is 40. So now it's basically just finding the missing angle of a triangle, which add up, subtract from 180, measure of KIM should be 50 degrees. Okay? All right, the measure of one exterior angle of a regular pentagon. Exterior, 360, divided by 5, because there's 5 angles, 72 degrees. Exterior, pentagon. So exterior indicates 360, pentagon indicates 5. All right, number 11, the most precise name for the figure is quadrilateral. All we know is it has 4 sides. So, just has 4 sides. Okay? All right. Last but certainly not least, in triangle PQR. So here's triangle PQR. Exterior angle to P is 70, which means its inside is 110. Exterior angle to R is 130, which means its inside is 50, which means that guy up there is 20. The question asks for which side, that means 2 letters, is the longest. Find the biggest angle that will point to the biggest side. Okay? All right, I expect that you should be able to do, actually, yeah, the 4 algebra problems on the back. If you need help, the first 2 are diamond method, the bottom 2 are quadratic formula, which has its own video.